Okay, there are these nice pre-monsoon thunder showers going on here in the city of Pune, where I'm sitting, which is unfortunately also a hotspot for COVID in the second wave. Let's hope the monsoon becomes normal by the time it arrives and COVID disappears as well. Anyway. The second section of the book is called Energies, and within Energies we start with this topic called Top of the World, where the book goes through the discovery of the stratosphere and some issues, and then come down to the troposphere and the climate change, and talk about the Earth system, and talk about how we are actually part of the Earth system, and trying to separate ourselves is going to be not a good idea. So let's go through that. The stratosphere was discovered by de Boer, I guess, a French scientist in 1902, where while sending balloons up through the atmosphere, he found that at some point the temperature stopped cooling and they were maybe even warming. And since then we have had a lot of discoveries about the stratosphere, so we'll go through that. This is from the book The Poetics of Space by Gaston Bachelard. One might say that the immensity is a philosophical category of daydream. One might say that immensity is a philosophical category of daydream. Daydream undoubtedly feeds on all kinds of sights, but though a sort of natural inclination, it contemplates grandeur, and this contemplation produces an attitude that is so special, an inner state so unlike any other, that the daydream transports the dreamer outside the immediate world to a world that has the mark of infinity. So there is some poetic description of the stratosphere. This is the image of I think Space Shuttle Discovery hanging in the stratosphere. This is probably taken by the Earth International Space Station. I'm not sure, but you can look it up. This is another one is from the colorful atmospheric layers. So this is called a limb view, where you can clearly see the upper atmosphere, gives you a sense of infinity to outer space, and you have the troposphere below that and the so-called limb. So that was taken by, I think, I forgot. Anyway, scientifically we know that the atmosphere has this kind of temperature gradient where the surface is warm because of the greenhouse effect, which we will come to. We won't go through the energy balance, but I've done it in other courses that you can look up, podcasts on that. At some point the UV of the atmosphere begins to affect the oxygen molecules and produce ozone, and together they absorb a lot of energy, so the cooling stops and then warming begins, and that continues up into the stratopause, and then you have the mesosphere, thermosphere, and so on and so forth. So that boundary between the decreasing temperature and increasing temperature between troposphere and stratosphere is called the tropopause. Tropos means turning over. We have weather. Stratosphere means layer, so it's not particles oscillating up and down, but horizontally along layers. And we'll see that tropopause is not a constant height from the tropics to the high latitudes, because the atmosphere gets colder and shrinks, and so on. So in the stratosphere we have the ozone layer, which saves our lives by absorbing the UV, high energy blue UV. We have weather balloons getting a lot of data. There are polar stratospheric clouds. There are some spy planes like U-2 that flew in the stratosphere. There are mostly planes flying at the boundary, but as you go to higher latitudes you could easily be in the stratosphere, because the stratosphere comes down with the tropopause, and so on and so forth. So we have the sounding rockets being sent out and various other activities. without going into all the details of the circulation and how it gets set up, which I have done in other courses again that you can look up. Quickly, the equatorial regions, low latitude regions, get warmed up by the sun. Earth is a sphere, more energy per unit area at low latitudes than at high latitudes. That warms the surface, evaporation, rising air, expansion, condensation, clouds. That condensation heating drives positive feedback, so the cloud tops go all the way to the tropopause and even go through the tropopause, sometimes into the stratosphere, depending on how energetic they are. And the air diverges towards the pole at the height, and you take the angular momentum and so on, and you produce things like the subtropical jet and the polar jets. And we have the circulation cells, the Hadley cell and the polar cell, which are called thermally direct cells, and we have a kinetic cell or a matching gear in the middle called the Ferrel cell. So you get another rain band here where there is rising motion between the polar cell and the Ferrel cell. But basically you have a tropopause that is at 15 kilometers or so in the tropics and drops down to 12 to 8 kilometers by the time you reach the poles, right? Stratosphere, the ozone layer is critical, but it's really a skinny layer, and it is produced, as we said, by UVC bombarding oxygen molecules, creating oxygen atoms which combine with other oxygen molecules to produce ozone, which absorbs UVC. So we get some UVB in the lower atmosphere, and we get lots of UVA. So this is the high energy UV that would damage our skin. So the width of the stratosphere is 10 to 31 miles, whereas this is about 10 miles in the deep tropics. We have surface ozone smog, which we are not going to get into, but it's part of the processes that OH radicals, NOx, the emissions from vehicles and so on together producing ozone in the troposphere as well, which is a greenhouse gas, very bad for health, and can also cause crop damages and crop yield loss and so on. Okay. There have been aircraft, U-2, which flew during the Cold War, secret missions to do reconnaissance. Was a massive plane, but the pilots were trapped in a little cabin, and for hours they would just image various activities of the enemies, let's say. Okay, but we know now that the problem of stratosphere can be serious if we begin to create damage to the ozone hole, and the discoveries by Sherwood Rowland, I think, and Mario Molina, they won the Nobel Prize, and Paul Crutzen did activity of NOx and how they affect the ozone as well in the troposphere. So that is just something we have now become very aware of. Montreal Protocol came along, CFCs were replaced by HFCs, but now HFCs have to be replaced because they are also very strong greenhouse gases and so on. Okay, so that is the top of the world, which is basically an introduction to the stratosphere. Why are we doing that? As you can imagine, we will look at what volcanoes do in the stratosphere and what geoengineering would mean for the stratosphere. Probably most of you have heard that there are ideas of going and sprinkling, reflecting or scattering aerosols in the stratosphere. Stratosphere has no weather. Troposphere has weather, so things get moved around and washed out quickly, whereas stuff that goes into the stratosphere can stay there for a long time. Not much exchange happens between the troposphere and the stratosphere. So the idea is that you can do solar radiation management by reflecting sunlight before it heats the Earth. But of course there are many issues that we'll come to. But first we'll go through something about the planetary weather, global warming, and emissions and so on. Okay, so that's the top of the world for you.